All right, and we are live. Welcome everyone to the webinar today. We're talking about building agents with LlamaIndex and Qdrant, taking you past the tutorial. We're going to wait about, I'd say about 5 minutes here, wait for people to flow in, and then we're going to go ahead and get started.
Cool.
Yep. How's your morning been, Saurabh?
Oh, pretty good. Pretty good. A lot of stuff going on right now.
Yeah.
For LlamaIndex. We're gearing, I was gonna mention during talk, we're gearing up for like a GA launch for Llama Cloud, and that's gonna be really exciting to share to a broader audience.
Hey, Christoph, what's going on? I see some people joining in. Glad to have some people in here this morning. As I mentioned, we're going to give it a couple minutes here before we get started. Thank you all for joining us this morning. Excited to talk to you about agents. All right, got some people still flowing in. Just going to give it a couple minutes here, give people some time to go ahead and join the webinar. Hello to everyone. Hey, Guerin Ho 96, what's going on? All right, I'm gonna give it till 10:03, and then we're gonna go ahead and get started. Okay, cool. Hey, Colleen. Hey, Casper. What's going on? I know that face from somewhere. All right. I'm going to go ahead and get started here today. So welcome, everyone. My name is Terry Damiba. I'm a developer advocate at Qdrant, and I'm joined today by Saurabh. Saurabh, you want to introduce yourself?
Hi, I'm Saurabh. I'm a founding engineer at LlamaIndex, and excited to give this little talk about agents with LlamaIndex and Qdrant.
Yeah, so Saurabh, thank you so much for joining. The way that this is going to go is first, I'm going to talk a bit about agents in general, and then I'm going to talk to you about how you can use semantic cache with Qdrant, LlamaIndex, and Camel AI to save yourself some time and resources. And then I'm going to pass it over to Saurabh, who's going to take you into LlamaIndex and how you can use LlamaIndex for agents. So I'm going to go ahead and get started here. And Saurabh, I'm going to take you off the screen and jump in. Okay, awesome. So I see some questions in the chat. Are we going to talk about Llama Parse? We'll get there. We'll see if Saurabh is talking about that. And awesome. I see, Christoph, you're building an agent for UBI. That's really cool. That's really cool. So today, as I mentioned, we're going to be talking about building agents with LlamaIndex and Qdrant. And specifically, I'm going to be talking about how you can accelerate your agents with semantic cache using Qdrant and LlamaIndex. So what are we going to learn today? First, we're going to talk about why agents are useful. Then we're going to talk about how to use Qdrant for semantic cache in an agentic system. And then we're going to finish by talking about the benefits of semantic cache. So in case you don't know, today the task XKCD turned 10 years old, and the task XKCD is basically a XKCD that makes fun of the fact that creating any kind of visual model is really hard in computer programming. And this is kind of a big milestone because today we see that these models are pretty easy to access. You can actually just use them for free, these classification models. So I figured I'd show you a XKCD about agents. This is a cool little one. The eagle has left the nest. Roger that. Alert the agents. will you stop that? And then at the bottom, my hobby is following field biologists around and interpreting everything they say as code phrases. And this is funny, but it also kind of ties into agents, right? Because when we think of agents, right, we're not thinking of this agent. We all know this agent. We're not thinking of these kind of agents, the one that might help you buy or sell a home. Not thinking of this agent, the kind that might help you get a better contract at your movie, or this agent, the kind that might help you end your life, right? We're talking about these agents that are AI agents. And when we think of AI agents, there's no real hard definition, but you basically want to think of it as something that is going to take output or stimulus, and then it's going to do something based off of that stimulus, right? So we've got these kind of semi-autonomous situations where you can automatically do things without having to go in and manually do it yourself. And the beauty of agents are you can actually have them, for example, talk to each other. You can have them, for example, do research for you. Whereas before, what you would have to do is go on something like ChatGPT and type in what animals are facing extinction, and then you get the result back. And then maybe you'd want to narrow that down by the continent. What you can do with agents is you can say, hey, I want you to write me a research report on the endangered species in the sub-Saharan African continent. And that agent is going to go ahead and do that for you. So that's the beauty of agents, is basically this idea of being able to send someone out in the wild the same way you might send out a real estate agent to make a deal for you on a home, where you give it instructions, you give it a budget, and then it's got a little freedom to kind of move within the rules. You know, if it's a real estate agent, we know it's going to come back with a house a little bit above your budget, little things like that, right? So this idea of something that's acting on your behalf to get a goal or task accomplished. And today specifically, I want to talk about semantic cache in the agentic workflow. And we've got this graphic here where what you want to do is basically follow the question and answer. So we see here, first, the user is going to ask a question. That question is then going to go inside of our embedding model. The embedding model is going to check, hey, has a query like this gone into our vector database? If it has, then we're going to retrieve the answer from the vector database. If it has not, then we're going to go to our large language model and return the result. So the idea here is basically, if you have your agents doing a task, and then in the future, you have your agents doing a similar task, instead of having to hit the LLM all over again, what you can do is you can actually just retrieve the answer from your database. So I'm going to pause here for a second and just let everyone absorb this diagram, as well as just check to see if we have any questions. Okay, doesn't look like there's any questions. Thanks for saying we're cool. We think we're pretty cool too. So now I'm going to take you into the code. And first, we're just going to install packages. So we got LlamaIndex, we got Qdrant, we got FastEmbed. And then here, I'm going to be importing some libraries. The ones you want to pay attention to are this Colorama one, which is going to allow us to print out in color. That's useful for agent stuff, because then you can tell the difference between which agent is participating in the conversation. And then we're going to be using this library called Camel, which is actually built on top of Qdrant to do your agent stuff. Saurabh later is going to show you how to do it with LlamaIndex, but I wanted to show you another option. And then we also have this time function that we're going to bring in to actually time our queries. This will allow us to see what's the actual benefit of implementing semantic cache with Qdrant. And then finally, we have our Qdrant client, as well as some embedding libraries. So what you're going to want to do is, first, you're going to bring in your environment variables, which I've got as secrets in my Google Colab notebook. And this is just a way to have your environment variables be kept safe. So before I jump into code, I do want to talk about embeddings, because this is something that is going to be important for the semantic cache, as well as any application that you're building using AI, really. So what we're doing here is we're going to take these words and we're going to turn them into numbers. Now, you're going to see that the numbers aren't exactly the same, but they're going to be similar, because both of these phrases are attempting to capture the same idea. we've got this linen kind of summery white shirt. And what our embedding model is going to do is it's going to turn these words into numbers. And you can see that the numbers are going to be similar because the words are similar. And that's also how our semantic cache is going to work. So if we ask our if we ask our agent to do something, and then we ask it to do something similar, the idea is that the agent shouldn't have to hit the LLM all over again to get an answer back. So in this example, we're going to be using the All Mini L6, just nice, easy, small model for testing. And then we're also going to be using Qdrant and memory for this test. So I want to talk about the different ways that you can use Qdrant. First, you can use it locally or in a collab notebook like we're doing here. Then the step above that is using it with Docker. The benefit of using Docker is that you can mount your volume and persist your data. So when you start dealing with larger data sets that you don't want to load up every time, that's when you'd go to Docker. And then finally, when you want to deploy your application to production, that's when you would go to the cloud. So you can kind of think of these steps that you take up as you go through your development process. And the beauty of Qdrant is all of your code can stay the same. The only thing that you're going to need to change is the parameter inside of this Qdrant client. As you can see, we currently have it in memory because we're working locally and we're just prototyping. So the first thing that we're going to do is we're going to actually initialize our client, and we're going to create a collection if the collection doesn't exist. So the way that Qdrant works is that we have these collections, and inside of our collections, we have our data. So what we're going to do here is create the collection, and then we're also going to get the embedding. So this is kind of the magical moment here where we're actually going to implement the semantic cache. So there's two different pieces to the cache, right? If I go back to this diagram that I had above here, the first step that we're going to have is we're going to actually search through the semantic cache. So we have a query that's come in. We have to see, hey, does this query already exist in our cache? The second step is if that query does not exist in the cache, we want to add it to the cache because whatever the response is, we want to have that stored so that if in the future a similar query comes in, we know to use the cache as opposed to hitting our large language model. And of course, the benefit there is that you don't have to use the resources that you'd be using if you hit the large language model, and the retrieval from your database is going to be a lot faster than retrieval from the large language model. So as I mentioned, there's two steps here. The first step is we're going to search through the cache to see if a similar query exists. And you can see here I've set the threshold at 0.85, and this is based off of a cosine similarity, but you can change this and mess around with it as you see fit. And then the second piece is actually adding to the cache. So here we're going to say, hey, this is a new prompt. We haven't seen it before. Let's add it to the cache so that if in the future something like this happens, we know that it's happened. And then to demonstrate this, I'm actually going to show you a demo here using Camel AI. So Camel AI, as I mentioned, is built on top of Qdrant. Students from, I believe it's the University of Oxford, came together, decided, hey, we need some cool agent stuff. This is an example of some cool stuff you can build with Qdrant. So if you're out there looking for inspiration, check out Camel AI. What Camel AI does is they create societies of RAG agents to create tasks or to complete tasks. So here I have some Camel AI code. And basically what this code is going to do is not only process the prompt, but also time the execution, because we want to see how much time do we save when we use the semantic cache versus when we just hit the large language model. And here I have a role play session where I have a chef and a nutrition expert. And the prompt that we're going to be working around is give me a dinner menu focused around garlic. So the rest of the code you see here is, for example, me limiting this to one message. This by default is 50, but in the interest of time, I've lowered it to 1. And then I'm also timing all of the runs. And then at the bottom here, I'm doing the first run, the second run, and also calculating the difference. So what you see happen here is I've already run this, and I'll run it again in a second, but I do want to just show it to you quickly, is we have this first run where we have our original task, which is give me a dinner menu focused around garlic. It was a cache miss, right? Because it's the first time that we've asked this query. So we generate the response using OpenAI. The agents are going to make that ugly prompt that I had into a beautiful prompt about creating a garlic-themed dinner menu featuring roasted garlic soup, garlic butter shrimp, garlic-infused veggies. We even have a garlic ice cream for dessert. That's kind of crazy. Wow, I'm getting hungry. Sorry. So here we see the user is talking, okay, create a recipe for the garlic soup, include the ingredients and cooking instructions. The AI assistant is creating the recipe. And we see that the total execution time for this step was it was exactly 57.50 seconds. And we also see that the response was added to the cache for future use. So then we're going to come back and we're going to ask a question that is similar, and we now retrieve the response from the cache. Whereas before we had to retrieve the response from OpenAI, or generate, I should say. Now we can just retrieve the response. And if we look at the time savings, it's pretty ridiculous. We're going to save 57.48 seconds because this only took 0.02 seconds to run. And if you remember, this took 57.5 seconds. So you're basically turning your process into something that took a minute into something that's going to take 2 milliseconds. And if we visualize this on a log scale, remember, log is a better way to visualize numbers when they're far apart, because if we didn't have a log here, this line would basically not be visible. You can see it's just a huge, huge difference in terms of speed, right? So this is an example of semantic cache with agents using Qdrant and LlamaIndex. And why would you want to use this? Well, if you want to go fast, right? I show you the chart here where you can see the difference. Here you can see the practical difference. And what I can actually do here as I end and look for questions is we can actually run this, and you can see here that the first run is going to retrieve the response from the cache now because we've already run this query. So that's a little example of how this works. I will be dropping this notebook in the chat if anyone is interested, and I'll be checking the chat now for any questions. So Dark Chaos, you say, can you use OpenAI large embeddings? Yes, you can use OpenAI large embeddings, but Qdrant actually has a built-in embedding library called Fast Embed. There's nothing wrong with using the OpenAI large embeddings, but what we encourage users to do is don't just stick with the defaults, right? You want to make sure that you're using the right embedding model for your use case. And the way that I like to think about it is kind of a 3-step process, right? The first step is, what's your modality? So what kind of data are you using, right? If you're using image data, you have to use the image model. But you can also use CLIP. So CLIP is something that's going to describe the image, and it's also an image model. So first, think about what modality do you want to use. Second, think about your use case, right? Are you going to be running an e-commerce site? Are you going to be running a chatbot for customer service, right? All of these different use cases require different embedding models because they've been tuned for those specific things. And then finally, you want to consider performance. So you have to ask yourself, what's more important? If I'm running a medical application, for example, maybe I don't need the results instantly. I need them to be accurate. Whereas if I'm giving people ads for t-shirts, maybe I don't need the most accurate ads. I can just have them show up quickly. And I see also, yep, so I see that, yeah, exactly. So if you have a use case that requires a lot of dimensions, someone mentioned that there's embeddings that have a lot of dimensions, and that's great if you have a lot of high domain content. And then someone says, how is this different than, say, storing the prompts in a Postgres database like Supabase and just getting the answer from that? So that's a bit like asking what's the difference between a vector database and something like Postgres or Supabase. And the difference is going to be when you start actually scaling out your application and looking to deploy it, you're going to see massive, massive, massive speed hiccups if you don't use something like a vector database when you're using AI applications. Qdrant was actually built by someone who was using traditional databases for these AI tools, wasn't getting the performance that he wanted, and then he built Qdrant from scratch specifically to store data for these AI tools. So if you have any more questions, just drop them in the chat. I'll be around. I do want to give the floor to Saurabh, though. So Saurabh, if you want to share your screen.
Sure, yeah. Cool. Let me share this.
Okay, so I see your use case is biomedical. Yeah. Do I have the specific Qdrant embedding tool? Yes, I do. It's called Fast Embed, and I will drop that in the chat.
All right. Let me know. Can folks see my screen?
No, not yet. And now they can, and I will be leaving. See ya.
Great. All right, cool. And yeah, hopefully you can hear me here as well. Let me start this presentation here. Yeah, cool. No, thanks you, Terry, for setting up this webinar, and to the whole Qdrant team as well. I'm really excited to talk a little bit more about kind of like how LlamaIndex and Llama Cloud kind of integrate with Qdrant to help you build these types of agent use cases. That's a really popular topic nowadays with all like the newer capabilities coming out from these various model providers. Like OpenAI has had function calling for a while, but now we have Anthropic. We have some open source models that support function calling as well. That I think has led to a lot of momentum in this area. Just a brief agenda about like what I want to talk about with the group today. I'm going to be specifically focusing on a specific subset of agents that is related to RAG. It's called agentic RAG, which I'll talk a little bit more about in the next slide. And then we're going to be actually showing you how to like set up RAG index using Llama Cloud with Qdrant. And then we're going to be talking about some of the more advanced techniques you can build on top of that, like various agentic RAG techniques. Oh, and actually, sorry, we don't have the last part yet. But yeah, so as far as agentic RAG, the sort of overall premise here is that, well, with the RAG in general, is that LLMs are great at understanding the language structure, and they're now starting to get even better at understanding various other modalities, such as images. But they don't necessarily have information about your domain, like your documents that are specific to, say, your company or whatever application that you're building. And RAG is sort of like a paradigm that tries to meet that need by injecting context about various documents from your input data into the context window of a LLM prompt. And that helps it to actually ground its responses and ground truth data that you're able to provide. And typically this is done through the sort of like traditional, nowadays traditional process of getting your unstructured data into a vector database and then pulling that data out when necessary as per a user's query. Nowadays what we're seeing is that RAG has become a sort of critical component of agent systems as well. Agents, in order to be able to make correct decisions within their function calling, tool choice uses, they need to have the proper context in order to know what type of information they're dealing with. And this is where like the two areas kind of blend together a little bit more. And what you'll see in like some of these in the notebook that I'm going to share in a little bit is that these retrievers that we set up on Llama Cloud and LlamaIndex in general can be set as tools for an agent to be able to retrieve from in order to give you a valid answer to a user query. So with that being said, today we're going to be focusing again specifically on agentic RAG, and sort of like the overall premise for that is agentic RAG is basically a method of using the emergent reasoning capabilities of large language models within the process of data retrieval as well as response synthesis for a RAG pipeline. So real quick, I'll just quickly also talk a little bit about Llama Cloud, which is sort of the project I've been working on here at LlamaIndex. Llama Cloud is our cloud product, which sort of takes care of the hard parts of RAG for you, so you can focus on your downstream use case. These are all like at a larger company. There could be dozens of engineers dedicated to this problem of building a solid, scalable ETL pipeline for getting data from your various data sources into a vector database of your choice. And Llama Cloud really aims to build that pipeline for you, so that you can smaller teams of developers can just use that product and focus on their downstream use cases a little more with a little more focus. So besides large scale ingestion, we also support various integrations. Obviously, we have first class support for Qdrant. We also have various data source connectors like to places like S3, Azure Blob, Microsoft SharePoint, Notion, so wherever your data might be. There's also a robust API for injecting any kind of data, like raw file uploads or just raw text content as well, so that you can kind of like you can build your own pipeline for inserting into Llama Cloud from any data source as well. There's also support for various embedding model providers. You'll see today we will be using OpenAI, and this also like takes care of a bunch of other aspects of RAG as well, like making sure that you don't have duplicate vectors inside of your vector database or like duplicate chunks. We also integrate with Llama Parse as part of the Llama Cloud ingestion process, so that you can get that full the full benefits of using a high quality parser like Llama Parse, where we convert any kind of PDF or PowerPoint or various other file types into a markdown format that LMs have a much easier time of interpreting. And then beyond that, RAG is definitely not a black box, as there's a lot of configurability involved in building a highly performant retrieval system for RAG. So there's various chunking strategies that you can tweak as part of the ingestion process. There's hybrid search, there's re-ranking. We also recently added support for multimodal indexing and retrieval. So you can also now incorporate, if you have documents with a lot of image data inside of each page, you can also now make use of those images and get the most relevant page screenshots as part of the retrieval API that Llama Cloud exposes. So yeah, now onto like some of the very specific techniques within agentic RAG. There's a few ones that I'll be talking about a little more concretely in our notebook, but I'll just give you a brief overview here. But yeah, like I said, it's agentic RAG is really all about using the emergent reasoning capabilities of LLMs to improve various aspects of data retrieval and response synthesis. And what I'll be showing today is sort of like using Llama Cloud to handle the data ingestion and retrieval part, while using LlamaIndex on the framework side to handle the sort of the agent loops that are involved in agentic RAG. I'll give you a brief overview of like a few of these that are listed here. Sort of the initial one that I think makes sense is just query routing, that perhaps you're familiar with if you've used LlamaIndex as well. This is really a foundational part of agentic RAG, as it sort of sets up a framework for you to be able to add on various other agent RAG techniques under it. So query routing is really where you have an input query, and you're able to use an LLM or any other. There's various other methods as well to basically select where to send that query to for response generation, right? So what you'll see in a bit is like you might have a query that comes in that's more quantitative in nature, and you might have a SQL database that has quantitative information that could satisfy that query. You may want to send that information towards this text to SQL query engine to answer that question. Whereas if it's a question that's more qualitative in nature, you might actually want to send that towards a sort of more traditional like vector search based query engine, which we'll also be showing in a bit. But the idea is that you can then tack on these other sub query engine tools within your query routing module to sort of expand the list of ways that you can handle various queries. Then there's also like query decomposition, which is also like part of this demo. So with query decomposition, you'll be able to take a larger question and split that into multiple sub questions, as well as using the aid of an LLM. There's modules within LlamaIndex to handle this. So some examples of questions that might benefit from query decomposition is things like multi-part questions. What is Uber's revenue and headcount? Might be split into what is Uber's revenue and what is Uber's headcount. These subqueries be processed individually using, say, like vector search or some sort of structured querying, and then those responses would be then collated into a final response using that LLM as well. They could be exploratory, so like just sort of a vague question of what are Uber's financials. An LLM could break that down for you into what is their Uber's revenue and operating expenses. Again, process those individually and then collate the responses back into a final response. And then also compare and contrast queries. So if you have multiple documents that you want to query across, you might have a question about what are Uber's and Lyft's margins. These might be two separate documents about Uber and Lyft. Those would need to be, this one question would be broken down into two separate questions and could be routed into two different documents for vector search as well. And then finally, there's also structured data querying, which I mentioned as well. This is where you might have data that's present within API or within a SQL database. So that could be represented in the form of tabular data, JSON, XML, or various other kinds. And you may want to be able to answer questions about the data within that as well. We have modules for handling JSON data and tabular data pretty extensively and have for a while. Text to SQL is a very popular sort of paradigm for this, which I'll be showing in this demo. And it's kind of like one of the most more interesting parts of agentic RAG as well, because you're actually describing the structure of a SQL table to the LLM and asking it to generate a query for you that could potentially fulfill this a user's query. So with that, I'll probably head into this sort of a demo for Llama Cloud. So what I have here is sort of the setting up for a setup for index within Llama Cloud. Again, sort of like the overall picture for what Llama Cloud does is it takes data from various upstream data sources. You can see we support quite a few here. Right now, I've selected a few files for us to upload here. These are all just like Wikipedia articles about various US cities. And then you can also configure a data sync that you want the data from these files to end up at. So here I've already set up a data sync for Qdrant. You can also kind of validate that this connection works, the API key is correct, and everything like that. You can select from various embedding model providers. We support quite a few here. Here I'm using Text Embedding 3 from OpenAI. Check that the connection is valid. Like I said, we also added support for multimodal indexing. So with this, if you have this toggle enabled, you can, as part of the ingestion process, we also store the screenshots for every page within your input files. And then during retrieval, we also then are able to match up the input query, the user's input query, with the most relevant screenshots to that query as well. So you can use that within your response generation as well. If for example, that there's complex charts or tables, et cetera, that would be relevant for the answering the query. And like I mentioned, we also have Llama Parse incorporated as part of this Llama Cloud ingestion process. So if you're familiar with Llama Parse, which sounds like some of you are, there's all the same sort of parameters for setting up Llama Parse ingestion within Llama Cloud as well. This has been a really great tool for a lot of developers. PDF parsing is a very complex and important part of high quality RAG responses. So it's always a high priority for us to make sure that this is a core component of Llama Cloud ingestion. And then beyond that, we also have, once you have parsed out your input files, there's all sorts of ways in which you can chunk those input files as well. So we have this more simpler mode for being able to set the chunk size and chunk overlap. Then we have various other modes as well for determining how to exactly chunk the data within your document. With that, I already have one set up here that's basically the same configuration that you saw. That's already all ingested. So here we can ask a simple question about these input documents that I've asked about. So we can ask say for example, how many people live in Los Angeles? Let's see, I haven't tried this query yet, but we'll see. So you can see sort of in this playground environment, you can kind of see what are like some of the what are like the sort of internal steps that are occurring within this within the chat engine and that's running on our backend. You can see some of the sources that were retrieved as part of this query. Obviously, like a relevant chunk from your input document might be like demographic data for this type of query. And then additionally, since we had multimodal indexing enabled, you can also see some of the relevant images that were used for response synthesis here as well. So yeah, that's sort of the overall idea for Llama Cloud. And I think yeah, hopefully that kind of paints a good picture. This is currently kind of in this closed beta, but we're going to be opening this up for GA very soon as well. And excited to like kind of see what like the whole host of feedback and like use cases that people build from this product as well. With that, I'll probably also then go into this notebook that I've prepared as well that uses this index for more of this agentic RAG as well. So I'll be walking through that here. Cool. So with this notebook, what I'm going to be doing is I'll be showing how you can programmatically access this index that we've created. You can see we show some code for being able to access this from both Python and TypeScript. So we'll be using that kind of code snippet here. Some sort of like setup stuff, but essentially this is also in our open source repo that I can link that we'll link as well. One of the first things that we're doing here is, as I mentioned, there's structured querying is a big part of agentic RAG. So we're loading up, initially we're just loading up a in-memory SQLite table with some sample data regarding population sizes of these various cities. This will be used for these sort of more quantitative questions that we might want to ask about these various cities, right? And then we also have this Llama Cloud index where we've uploaded these Wikipedia articles about these various cities for more of these like qualitative questions. What you'll see here is that we wrap these two into query engine tools. We provide a useful description for each of these tools. This is going to be useful for when we later on use function calling API through the LlamaIndex framework, as these descriptions allow the LLM to decide when to route a particular input query to either of these query engine tools. So it's very important to like make sure you tweak these prompts properly for correct routing purposes. Once you have those tools, you can you can start by setting up a workflow, which is again like a relatively newer concept within the framework. So the workflows are kind of like what we've kind of like built internally as sort of your gateway into productionalizable agents. So this is sort of the router agent that we've created for this particular use case. One of the first things it does is prepare like your input chat history with your input messages, and then it also sets up the LLM to start responding to these input chat events with these tools that we've set up, right? So these tools are passed in embed, but essentially it's the same tools that we set up here with Llama Cloud and SQL tool. One thing I'll just note quickly about this is that we also support we also have allow parallel tool calls here as well. So there if the LLM decides that it wants to use both your SQL tool plus your vector search tool with the Llama Cloud Index, it can choose to do both and then collate the responses as well in the final response generation. So once you have that set up, we can try to run some queries here. So like for example, which city has the highest population? As you mentioned earlier inside of this prompt, we mentioned that this tool, the SQL tool, contains information about the population and state of each city located in the U.S. Therefore, we see here that our agent is able to correctly select the SQL tool to answer this question and give a final response of New York having the highest population among all these cities. Additionally, like we can also ask more of these qualitative questions, such as where is the space needle located? That's not information that was present inside of our SQL tool, so it uses our vector search tool and is able to give this answer of Seattle on Queen Anne Hill. There's a more qualitative questions, again, just sort of showcasing like the power of this sort of like routing workflow that we've set up to be able to dynamically decide between which of these various subtools to pick here. Some other interesting things I'll just quickly note as well regarding agentic RAG. Let's see. Yeah. So there's a few other techniques as well that are definitely worth looking into and also supported by our framework. Corrective RAG, CRAG, is sort of interesting as well. This is where you use an agent to evaluate the retrieved chunks that are retrieved from your vector database as a result of like semantic search against the user's input query. And if the LM agent deems that none of the retrieved chunks are actually relevant to the input query, then you can have it route towards another data source to search from. Typically with CRAG, that's been like a sort of web search tool, but you can also imagine that being some other like broader general purpose search tool that might be relevant to your domain. With hide is also really interesting hypothetical document embeddings, and with that, the idea here is instead of so you have all various chunks from your input documents embedded and stored inside of your vector database. Typically, what's done in like basic RAG is that you take your input query, derive the embedding for that input query directly, and then try to match that against the embeddings inside of your vector database. With hide, the approach is really to first to have the LLM almost like hallucinate a hypothetical answer to that input query, and instead of using that hallucinated, potentially inaccurate answer to that input query, you instead just use the embedding for it and use that to match against the documents inside of your vector database, the chunks inside your vector database. And that the idea there is that the hallucinated answer might be semantically closer to the ground truth information that you've embedded in your vector database than the query that might have its own structure that's different than the ground truth answers in your vector database. But those are again, yeah, just very, very interesting, worth looking into. Hide in particular, I've heard in general, like some people swear by it, but definitely just worth experimenting with. One other final thing I'll note with anything related to agents and agentic RAG is the importance of evals, and our framework also kind of supports various tools for evals, both for determining whether the responses generated by an agentic RAG system match up with ground truth labeled answers that you might have, and also for things like being able to evaluate the relevance of retrieved chunks to the input query as well. So you can basically use an LLM as a judge for these various evaluation metrics. And as long as you're trying to add these incremental changes like query decomposition, corrective RAG, hide, as long as those eval metrics keep improving with these additional techniques that you can add, you can be relatively more certain that these techniques are worthwhile for you and are actually improving your response generation. But yeah, that's kind of my side of the demo here. Happy to look at any questions that folks might have.
Hey, so one question we got was, how would you get the page number in the metadata of the chunk using Llama Cloud?
Awesome. Yeah, that's a great question. So yeah, maybe we'll share my screen real quick again. Sure. So like I mentioned, we have a fairly robust API for Llama Cloud as well, and that includes an API for each of the retrieved chunks. So I'll just show like an example of that as well here. So if we go to the chunks here, you can see all the metadata that is attached as part of Llama Cloud ingestion process, and that includes the page index labels. So you can see what page if this chunk, for example, this could be chunked in a way that it spans across multiple pages. So we give both the start page index and the end page index as well. In this case, it was just on a single page. But yeah, hopefully that answers that question.
We've got another question asking, how do you feel about coding AI tools? Do you use Cursor?
Oh yeah, yeah. No, internally in LlamaIndex, we actually love using Cursor, in particular, like using it with like the various like OpenAI models as well. But yeah, no, it's great, and actually really would be really exciting to see more tools like Cursor within other domains besides coding as well. I think there's a lot to be built in terms of applying like agents and RAG towards other domains and workflows beyond software engineering.
So when you say that, do you mean maybe something that would be able to analyze contracts for companies that can't afford to hire counsel?
Oh yeah, yeah, absolutely. In particular, like I think with Cursor, what they do fairly well, and is that it's sort of like they're not trying to fully automate process just quite yet. They're trying to sort of have this sort of LLM agent in your workflow with you and assisting you as you're doing your work. And I
Yeah.
think probably, yeah, I think that's just that paradigm in terms of UX in general is I think there's a lot of opportunity there.
Yeah, I think about it a lot like chess engines in the sense that the best chess players are only made better with chess engines. I can't beat
Right.
Magnus Carlsen even if you give me the best chess engine. But of course, Magnus versus Magnus, one of them having the chess engine, the one with the engine will win.
Right.
So it's just going to duplicate your skills or multiply, if you will.
Exactly.
And then we have a question, how does Llama Index workflow differ from LangGraph?
Oh, sure. Yeah. I mean, let me stop sharing my screen here.
I can take it off. Okay.
Oh yeah. Yeah, no, it's a good question. I think so with workflows, kind of our impetus was sort of again like kind of like still within the RAG paradigm. Like LlamaIndex has been focused on RAG for quite a while, and agents is sort of like our way to kind of bring sort of this agent construct into a production environment. So what we've done is put a lot of work into being able to build an agent framework that similar, maybe like similar to things like Kubernetes in some ways, where you can have a control plane that's centrally located, but your workflows, like the agents, can run from anywhere. This is particularly useful for like say like enterprise customers or clients that like have that sort of requirement where they may have their own customers that have their own data requirements of where their data can reside in, but then the control plane metadata can reside inside of their own environment. So yeah, it's actually like pretty useful for a lot of large companies like that.
Yeah, and that question came from Dark Chaos, who mentioned earlier that their use case is medical and biomedical documents over 500 pages. So it makes a lot of sense why they would be interested in that. We've got a question from Farnood. Is it possible to filter the documents that the agent will look into for gathering the response?
Yeah, yeah, for sure. So I think, yeah, so like with that, we have metadata filtering as part of the retrieval API that Llama Cloud exposes, as well as like just the framework in general exposes. So like with that, there's a way to batch assign metadata to all the files inside of your index within Llama Cloud. You can do similar things with the open source framework as well. But that would be essentially the way to go with that. One thing that would be maybe like a still kind of like useful thing to look into is this project we worked on like way back last year called SEC Insights, where it was a similar problem of we have various SEC filings that we want to be able to do RAG chat over, and we basically built a subquery engine tool for every document in there, and that subquery engine tool was operating over the same collection, but just filtered down view according to the metadata for like the ticker symbol, and then whether it was a 10K or 10Q and what year and whatnot as well. So yeah, oh yeah, there we go. So yeah, that's an open source repo that still is kind of useful in terms of deriving the overall techniques from.
And then we've got another question from Dark Chaos, who says, LangGraph is essentially LangChain's version of your workflows. How do the workflows differ?
It's a good question. I think, yeah, it's similar to kind of what I said a bit earlier. I think like I think the overall premise is sort of like maybe like geared towards like this sort of use case around being able to have separation between control plane and your data plane. So I think like Llama Deploy in particular is a project that enables that. But workflows, even on the open source side, like you can use that beyond just like agents as well. In fact, what you might even see is like to just use it for the retrieval part is actually kind of useful. You can like have each step of retrieval be represented as a step within a workflow. And the reason why that's useful is because then you can now plug into like kind of the observability tooling that we have built into workflows as well. So you can now like kind of see each step of that retrieval step alone, the overall retrieval step alone, represented it through like some observability tools such as like OpenTelemetry or Arise Phoenix, etc.
Awesome. And then another question, Qdrant allows filters in their vector database. How do you use both metadata on Qdrant filters? I'm assuming that was a question. So I think they're asking, how could you use filters with Qdrant as well as LlamaIndex?
I see. Yeah, I mean, yeah, for sure. So like we basically have these integrations with vector databases such as Qdrant, and they expose their own metadata filtering APIs that we're basically just using under
Oh,
the
sorry.
okay, batch.
Yeah, you got it.
Okay, so batch metadata filters. Maybe yeah, actually maybe that's an area that I'm like as familiar with. Do you have more context maybe on that one?
Yeah, so I guess Dark Chaos, this might be a one-on-one conversation because I'm a little confused as to the question you're asking. Are you saying, can you use batch data with filters? If so, the answer is yes. If you're asking something different, then let's try to connect.
Yeah, for sure. And like, yeah, both of these, like LlamaIndex and then Qdrant, like support fairly complex metadata filtering queries. So you can kind of query across your entire collection at once, obviously,
Yeah.
and like do ands and ors between these various like metadata filtering expressions.
Yep. The classic use case that we always point out is e-commerce. So if you had something like a shirt, you could not only come in and tell us what the quality of the shirt was, but also what material it was made in, what the brand is, what the price is, all of these things. You can just go in there and filter. And does anyone have any other questions? I'm checking the chat. Speak now or forever hold your peace. Once again, thank you so much for joining us, Rob. Really awesome seeing the stuff that LlamaIndex is working on. I think you guys have a bit of a magic 8-ball. It seems like anytime you're working on something, not too soon after, it seems like you made the right choice. It's like to see what LlamaIndex is working on. They're my Groundhog Day, the canary in the coal mine.
That's so nice to hear. And yeah, we love like partnering with Qdrant on all these things too.
And
great.
Dark Chaos, as far as I understand that, yeah, you should be able to do that. You have your metadata, you can classify it based on the diagnosis. And then, yeah, you can use LlamaIndex to add the metadata and filter a Qdrant. Yep, you should be able to do that. And if you need any help with that, feel free to reach out to me on Twitter or LinkedIn. The presentation will be published. This video will be public. And yes, you will be receiving the links to everything. I'm assuming you don't mind sharing your links.
Yep.
Okay, so yeah, we'll have all those links sent out to you after the presentation. Also, great name, LOL02, fine. Joe, thank you for joining us. All right, it looks like our questions are wrapping up here. I'm going to end the stream. Once again, thank you so much to LlamaIndex for joining us here at this Qdrant webinar. Looking forward to seeing everyone again in the future. Have a nice day.
See you.